Hey y'all, we are Memphis Kim University and we are back for another Calculus Done Wrong lesson where we wrong calculus before calculus wrongs us. And today what we're going to be doing is we are going to be taking derivatives of general functions. So instead of functions like e to the x or sine of x or ln of x, we're going to be taking derivatives of functions that involve f and g's. We also want to be able to plug in x values or numbers into our general functions like f and g's derivatives. So what we're going to do is we're going to use either a table or we're going to use a graph. And we're going to be gathering information in the table and the graph. These will have f and f prime values, g and g prime values in order to evaluate these derivatives of these functions at certain numbers. So that's going to be our goal today. We're of course going to be using our normal derivative rules. So that's the power rule, that's the product rule, the quotient rule, and of course the lovely chain rule. And we're going to be applying the rules that we know just to these functions right here. Some of my students get confused on why we're doing this because it seems like it's all review, and it basically is. It's actually going to be easier than some of the derivatives that we've taken in the past because we don't need to know the unit circle, for example. We don't need to know square roots or how to add fractions together usually. All we're going to do is we're just using values in a table and multiplying and dividing numbers when they arise. So sometimes we need a little gentle lesson. This is going to be a gentle lesson. The point of this lesson is to make sure that we do know how to use tables and graphs in the context of what we need. But let's get started. So in this case, we are again doing differentiation rules. So differentiation rules of general functions. So we're going to be taking these nice little derivatives. So the first half of the video, what we're going to do is we're going to use a nice little table. So let me draw a table real quick. So it's going to have x, f prime, g, and g prime values. So let's erase this g and g prime values. Going to be a nice little table here. Let's see that. Let's not make the table too crazy. So we'll just have this. And then we'll have 3, we'll have 7, and we'll have 8. So these are going to be my values in the table. And I'm just making these values as I go. So I'm just going to populate this table with random numbers. Let's put 7 right here. Let's put 8 right here. Let's put 3 right here. And let's just put in random numbers. So 4, -1. Probably should keep these values as small as possible. So let's change this to a 2. Let's do this as -1. Let's do 5 and -2. Finally, last row, random numbers as well. Let's do -3, -4, and a nice little 1 because sometimes it's nice to multiply by 1. So again, what we're going to do is we're going to use this nice table. For example, we're going to use the fact that f of 7 is equal to 4, or g prime of 8 is equal to 1, or g of 3 is equal to -1. And we're going to take derivative of functions that involve f and g's. Then we're going to take the derivative and plug in values using this table. So my first example is going to be fairly easy. H of x equals, let's do 3f of x minus 2g of x plus x squared. And we do need an x, so we're going to try to take this derivative. So the instructions of the question is take this derivative of this function at x is equal to 3. So basically what we're going to try to do is find h prime of 3. But in order to find h prime of 3, you first need to find h prime of x. So let's do that real quick, h prime of x. So as we're taking these derivatives, let's of course be careful of our derivative rules. First off, this one is pretty easy. Sums and differences are great because it breaks up the question and we can do each of these individually. What's the derivative of 3f of x? That's the same thing as the derivative of 3 times like sine of x, which is 3 cosine of x. If you have a derivative of a function times a constant, just write that constant down. So just write that 3 and then take the derivative of f of x. Well, the derivative of f of x looks like it is going to be f prime of x. Don't know why I pointed to the table because we're not ready for that. What's the derivative of minus 2g of x? That's very similar. That's just going to be minus 2g prime of x. And then finally, what's the derivative of x squared? That's just 2x. So now what we're going to do is we're going to plug in 3. H prime of 3 equals 3 times f prime of 3 plus minus, that's a minus here, 2 times g prime of 3 plus 2 times 3. So again, right after you take the derivative, just plug in the number that they want you to plug in. So in this case, we're going to plug in 3. And before what we would do is we would just evaluate this, but I don't know f prime of 3, I don't know g prime of 3. I start panicking, what am I going to do, what am I going to do? But it looks like I have this nice little table here, so that should tell me the answer. So let's do this real quick here. So it's going to be 3 times f prime of 3. Well, f prime of 3 is going to be 2, so it's going to be 3 times 2 minus 2 times whatever g prime of 3. G prime of 3 is negative 3, so it's going to be times negative 3. Just be careful with negatives, just like normal. Then it's going to be plus 2 times 3. Well, this doesn't look too bad. Looks like it's 3 times 2, and then this minus and minus will become plus, so it's plus another 3 times 2, plus another 3 times 2. That's just 3 sixths, so the final answer here is 18. So hopefully you can see what we're doing here. It's not going to be very intimidating. Again, all we're doing is taking derivatives, and as we take these derivatives, after we're done with them, we're using our normal derivative rules, but after we're done taking the derivative, we're just going to plug in a number and then use the table to evaluate that derivative at a certain number, whatever number we want. So let's do some harder, challenging more questions, because even if this is a gentle lesson, we do want to still be challenged because challenges are fun. So let me just do a new function here. So my new function is going to be 4 times f of x times g of x. And we're going to evaluate it at, let's say, 8 this time. So this is going to be 8, and we're going to find h prime of x. So our goal is to find h prime of x so that we can finally find h prime of 8. So let's do that real quick. So h prime of 8. So let's get going. So again, anytime you're taking derivatives, you do need to be consistent with your derivative rules. So even if we have a product here, we need to do, of course, the product rule. And while you might think of this as f of x times g of x, the main error people make, in my opinion, is what to do with this 4. So I think it's easier to attach the 4 to the f of x. So I'm going to think of this as 4f of x times g of x, as opposed to just f of x times g of x. Then I'll be more likely to distribute the 4 to both sides of the product rule. So let's get started. So again, our goal will be h prime of 8, but we're not ready for that yet. So let's change that to h prime of x, and let's go for the product rule. So what's the derivative of the first thing? Well, that's going to be 4 times f prime of x. Then, because we took the derivative of the first thing, we're going to keep the second thing the same, so that's just g of x. Then we're doing plus, because this is the second half of the product rule. Because we took the derivative of the first term in the first half of the product rule, we're going to keep the first term the same in the second half of the product rule. So it's going to be 4f of x. And then because we kept g of x the same for the first half of the product rule, now we're going to take the derivative of g of x. So that's g prime of x. Notice that my 4 is distributed to both halves of the product rule, and that's what I want. So again, it's derivative, keep the same, derivative. So now all we have to do is plug in 8. So that shouldn't be too bad because that's what we want to find, h prime of 8. So it's going to be 4 times f prime of, so we can make a better f prime of 8 times g prime of 8 plus 4 times f of 8 times g prime of 8. So now I'm just going to use the table. So it's going to be 4. Don't underestimate the table. Sometimes students do mess up the table. It is an easy step, but you want to read it pretty slowly. So f prime of 8, that's negative 2. G of 8, I don't think I have g of 8, I have g of 8. So for some reason I wrote a prime here, but it was derivative, keep the same. So this is just g of 8. G of 8, it looks like it is 3, so times 3 plus 4. Now I need to do f of 8, but again, I'm just reading this table. F of 8 is negative 1. And then finally, g prime of 8, we made that 1 to make the numbers nice. Then all you do is just multiply, and you should be good to go. So negative 2 times 3 times 4, that's negative 6 times 4, that's negative 24. Let's subtract off another 4 because it's 4 times negative 1 times 1. So the final answer is negative 28 in this case. So hopefully you see that the derivatives are still the same. If you're careful with your product rule, just like normal, where you're really being careful with this 4, you should be good to go. Just take that derivative using the product rule, and then finally plug in 8, and then use this nice right column of this nice table to evaluate the derivative of h of x at 8, meaning to find h prime of 8. So that's that question. Nothing too crazy there. So let me just erase this guy again. Let's do maybe 2 more questions using this table. So the next one I'm going to do is I'm going to do, let's see, I need to make it work. So I'm going to do f of g of x Then I'm going to add 6x at the end of this. And what I'm going to do is I'm going to find the equation of the tangent line. So I'm going to up the ante a little bit. I'm not just finding h prime of a certain number. I'm going to try to find the equation of the tangent line. Well, we need to specify which function we want to do it to, but of course this is going to be the equation of the tangent line of h of x. And then we're going to try to determine a number. And the number I want is I'm going to choose the number 8 because I believe I know what g of 8 is. Actually, no, let's do 7. 7 works better. 7 is the number I need. So we're going to do it at x equals 7. So a little bit of review. This was a previous derivative topic in this playlist, tangent lines. But anytime you have a tangent line, remember you just need two things, a point and a slope. That's what a line is. And then what does the word tangent mean? Just the word tan. Well, that means that the slope will be the derivative. So we need a point and a slope where the slope is the derivative. So let's do that real quick. So I'm going to write my point first. So it's going to be 7 comma something. And what I'm going to do is I'm going to plug in 7 into h of 7. Keep in mind that this is not products. This is not f of x times g of x. This is composition of functions. So g of x is nested inside f. And it's just going to be a composition of functions. So what you would do is you would first plug in, if I wanted to plug in 7, I'd first plug in 7 into g. So let's do this let's actually do this work, h of 7. So I want to find this point, I want to find this y coordinate, so I'm plugging it into 7. Let me erase this and put a little bit more space. So what I'm going to do is I'm going to plug in 7, but again, it's composition of functions, so it's f of g of 7 plus 6 times 7. So 6 times 7 is 42, but this is not f of 7, g of 7, this is find g of 7 first. So let's find g of 7. G of 7 is 8. And then find f of that, so that's negative 1. So it's negative 1 plus 42, which is 41. So this is the y coordinate of this point. Again, we're doing tangent lines, so you do need a point and a slope where the slope is the derivative. So that was the first step. That was not the calculus step. That was just plugging in the numbers using a table. Now for the calculus step, let's take the derivative. How do you take the derivative of f of g of x? Not the product rule, because it's not a product. It's actually our favorite rule, the chain rule. Because we have a function within a function, that's composition of functions. Never forget the chain rule. It's the best rule in the world. So this is actually how the chain rule is usually presented. What's the derivative of f of g of x? Well, that's just going to be f prime of g of x times g prime of x. All good and ready to go. Let's plug in our number here because again, slope, equation of the tangent line is point and slope where slope is the derivative. So we do need the derivative. H prime of 7. So it's going to be f prime of g of 7 times g prime of 7. Actually, I forgot this plus 6 because I was so excited to take the derivative. I know you are very, very excited to do the chain rule, but after the chain rule, just finish the question. So what's the derivative of plus 6x? That's just going to be plus 6. So we need to find plus 6 at the very end of this. I was so excited to do the chain rule that I forgot about this, but I caught my mistake, so everything was good in the end. Let's find g of 7. Well, g of 7 again is 8, and then f of 8 is negative 1. So this is going to be negative 1. All of f prime, negative 2. Let's not do too many steps at once. I'm confusing myself. So let's find g of 7 first. Then find g of 7. It's going to be 8. So it's going to be f prime of 8. Then g prime of 7. That's in the table. That's going to be negative 4. And then finally, I do not want to forget this plus 6, so let's write plus 6 right here. Sorry, my work is a little bit messy. Sometimes you get a little bit messy when you're doing math. Finally, we're going to find f prime of 8, not f of 8. That's where I messed up earlier, but it's f prime of 8. That's negative 2. So it's going to be negative 2 times negative 4 plus 6. Well, negative 2 times negative 4 is 8. 8 plus 6 is equal to 14. So this is going to be our slope. So now let's write the answer in this lovely box right here. We're going to use point slope just like normal. Y minus the y coordinate of the point. Y minus 41 equals the slope, which is 14 times x minus the x coordinate, which is 7. So this is the equation of my line. So even in these weird funky questions where the function is in terms of f and g's and not functions that we're used to, we can still answer questions like equation of the tangent line. How do we answer these questions? Well, we need a point and a slope where the slope is the derivative. To find the point, what we did is we plugged in 7. We plugged in 7 using this table, but we kept in mind that this is composition of functions. and not product rule, product of functions. So that when we took the derivative, we didn't use product rule, which is used for product of functions. We used the chain rule, which is used for composition of functions. So it's f prime of g of x times g prime of x. Then I was being a little bit too bold for my liking, and I slowed down a little bit. So what I did is I plugged in 7, probably best to slow down. When you plug in 7, you slowly do a little bit of work, and you'll end up getting that the slope is 14. Finally, you write the point and the equation of the tangent line in point slope form. Y minus this y coordinate that we found equals the slope, which is the derivative, times x minus the x coordinate. So that's all it is. Let's do one more question. Let's not do equation of the tangent line. I think you know what to do. Point and slope, where slope is derivative. Let's just bring it back to just the derivative, but maybe a little bit harder of a function. So I'm going to erase this right here. I'm going to erase this. I'm going to erase this. So let's say we're going to take the derivative of h of x, and we're going to take the derivative of f of, let's say, 2x minus 1, and we're going to write a cube here. And finally, we're going to multiply this by, let's just say, a nice little x. So let's bring back the product rule a little bit. So what we're going to do is we're going to take this derivative, and we're going to try to take the derivative and evaluate it at the number. I believe the best one that will work is 2. So let's get started. So again, what we're doing is we're taking this derivative and evaluating it at 2. So first off, what we need to do is we need to take the derivative. But sometimes when we have these harder derivatives, the thing you want to do is you want to rewrite the function. So just like when we took the derivative of sine squared of x, we're being lazy here, and sine squared of x is the same thing as sine x squared. But if you write it like this, it's more obvious what you're doing here. You're doing the product rule, or not the product rule, the power rule. You're rewriting this as a power where the squared is on the outside, so it's easier to use the power rule. So all it is you take this little 2, drop it to the front, so the derivative would be 2. Then because of the chain rule, you would keep this the same. And then finally, you multiply by the derivative of this inside function by the chain rule, which is cosine of x. So that's going to be the derivative of sine squared x. So we're going to do the same strategy here. What we need to do first is we need to take the derivative, but before we take the derivative, we want to rewrite this function so that it's easier to employ the chain rule. So I'm going to rewrite it as f of 2x minus 1, all of that to the cube, and we're going to multiply it by x. So this is what I'm going to take the derivative of. So let's take this derivative. It is going to be quite nasty because it does employ power rule, but I think we're going to be fine. So let's take this derivative right here. First off, I'm going to keep this the same because it looks like it's kind of weird, so I'm going to not deal with that now. And I'm going to take the derivative of the second thing, which is just times 1. So if you want, you can write times 1, of course. Then we're doing the second half of the product rule. We're going to keep x the same at the very end, and I do need to multiply by the derivative of this little beast of a guy. But again, once we write it like this, hopefully you can tell how the derivative works. There's really 3 functions here. There's a cube, which is the outside function. There's an f, which is the middle function. And then there's a 2x minus 1, which is the inside function. So I'm going to call the cube the outsidus, even if that's not a word. So what you do is you take the derivative of the outsidus. What Snoop Dogg told us to do is to drop it in the front like it's hot, and then subtract 1. So it's going to be 3 times f of 2x minus 1 squared. But that's only the derivative of the outside. Now we need to multiply by the derivative of the inside, so it's going to be f prime of 2x minus 1. Finally, we need to multiply by the derivative of the insidus function, which is still 2x minus 1, so that's times 2. And then finally, we had this keep the same of the x, so we're going to write 2x here. So even if we were squeezing it in the end, this is the derivative of this guy right here, or the second half of the product rule. So I'm going to repeat myself. I take the 3 to the front, boom. I don't change the inside at all. Whatever was in the brackets stays whatever is in the brackets. I subtract 1 from the exponent, so it becomes 2. Then I multiply by the derivative of f of 2x minus 1. That's f prime of 2x minus 1. But there's an insidus function. There's a function within the function. So I need to multiply by the derivative of 2x minus 1. That's times 2. And then finally, I kept the same. So there's that x at the very end. So pretty crazy chain rule. But now we're done. Now all we have to do is plug in numbers. So we're going to do h prime. Again, we are plugging in 2. So when we plug in 2, looks like we're going to get f of, well, 2 times 2 is 4. 4 minus 1 is 3. So when you plug in 2 into any of these parentheses, it's going to be 3. So we're going to do f of 3 cubed plus 3 times f of 3 squared. This is not going to be fun, but let's just persevere. Times f prime of 3 times 2 times, and then keep in mind that we were plugging in 2 into this x, so don't plug in 3 for this. This is going to be times 2. So now let's use the table and see what the table has to offer us. Well, f of 3 is kind of annoying because it's 7, but it's 7 cubed then, plus 3 times 7 squared times, well, this is going to be a pretty giant number, but it's going to be 2 times 2 times 2. So it's going to be 2 times 2 times 2. So let's be a little bit clever here. The work is still going to be very nasty because of these 7s, but let's try to multiply this in the end because we've already worked so hard. So this is going to be 7 cubed plus 7 squared. And it's going to be 2 times 4 times 2, which is 2 times 4 times another 2. So I believe that's going to be 8. 2 cubed is 8. 8 times 3 is 24, so it's going to be 24. So we can factor out a 7 squared, which is 49, and it's going to be 7 plus 24. So all we have to do at the very end is a stupid 2-digit multiplication, which is 49 times 31. I don't know how the numbers got that bad, but we can just do it on the side here. 49 times 31 doesn't look too bad because it's just 49, 0. No shame in doing work on the side. 3 times 9 is 27. 3 times 4 is 12. You get 140, 14. Then it looks like we're going to have, as the answer, let's just box it right here. It's going to be 9, 1, 5, 1. So this is my final answer, a lot bigger number than I expected, but we had a crazy function. The more important thing, of course, was just taking the derivative correctly. So let's review ourselves. What we did is we did the product rule. We kept the same derivative, but in order to take the derivative of this little critter right here, what we did is we rewrote it. We wrote it as cube so that the cube was on the outside of everything. So it was easier to employ the chain rule as we did this. We dropped the 3 to the front, subtracted 1. We multiplied the derivative of f of 2x, which is f prime of 2x minus 1. And then furthermore, we multiplied the derivative of 2x minus 1, which is times 2. We didn't forget this times x because I was keeping the same from the product rule. So the times 2 was part of the chain rule. This times x was because of the product rule. Then we plugged in 3. Unfortunately, when we plugged in 3, we got 7, and 7 is a massive number. But we did a little bit of clever tricks to make the work a little bit easy. But the actual math isn't the most important thing, of course. What's the most important thing by far is just taking the derivative correctly, using the chain rule, using the product rule, and perhaps rewriting it to make our lives a little bit easier. But that's enough for this table. It got a little bit out of hand, so let's erase this and let's change it to a graph. So what I'm going to do is I'm going to try to do these same questions, but instead of a table, it's going to be a graph instead. So I'm going to erase this. I'm going to erase this. Looks like we only need one quadrant here, so I'm going to draw a nice little graph. Let's put 1, 2, 3, 4, and 5 on this graph. Let's put 1, 2, 3, and 4 on the y-axis. I'm going to make my f go from here to here. Then I'm going to let it go up 1, up 1, up 1. So let's just make it go all the way to here. So again, we're going to do the same exact thing as the previous examples, except instead of a table, we are going to use a graph. But I need to draw a nice little graph in order to use it. It's going to be like this. And then my g function, so this is going to be my f function. I'm going to have 2 functions just like the previous example. My g function is going to be a little bit weirder. It's going to start off as a horizontal line. Let's do that. And then it's going to go down a little bit. So let's say it goes all the way to 3. And then let's say it goes and meets this point right here. So it'll go right here. So this is going to be my g graph. This is supposed to be a horizontal line. So if you can't read my graph, let's just label some important points. This point is 5, 3. That makes sense. Then this one is going to be, because we rose 2, this is going to be the point 3, 4. And then this point, of course, is 2, 0. So hopefully when you're doing your tests, your graphs will be computer generated, but sometimes it's nice to appreciate a nice hand-drawn graph. So again, what we're going to be doing is we're going to be taking the derivative of functions like h of x still, h of x, and we're going to be taking this derivative. Let's take the derivative of, let's say, g of x plus x over 3f of x. And again, we're going to plug in a number. In this case, we're going to plug in the number 1. So what we need is, we're going to do the same strategy. We're going to take the derivative using the x's, and at the very end, we're going to plug in 1. But instead of a table, we have a graph here. So what we need is, we need to know what f and g values are and what f prime and g prime values are, because they're not as clear as a table, because the table just literally gives you the answers. Here it's a graph, f and g, and f prime and g prime values. But how are we going to find these values? Well, keep in mind that these are graphs of f and g, so f and g. Well, it looks like f and g values are going to be just the y values of this graph. Nothing too crazy. Then I ask, what is going to be the f prime and g prime values? But remember that f prime and g prime are derivatives. Derivatives are slopes of the tangent lines. But because these functions are just simple lines, the slope of the tangent lines, or the tangent lines to these graphs, are going to be the lines themselves. So how do you find the derivative? Well, the derivative is the slope. The slope of the tangent line is the line itself. So it's going to be the slope of these guys. So when we want to find some slope values, we're just going to find the slope of these line segments, depending on what point it is. So let's get started. Let's take the derivative of this. So we can have some space here, h prime of x. So again, take the derivative, plug in a point using the graph instead. So here, notice that we have a quotient. Be careful of quotients. You do need to employ the quotient rule. So let's do that real quick. As we're doing the quotient rule, we're going to say the rhyme, low d high minus high d low over low low. But we need to be very, very careful of parentheses, just like normal. So low is going to be this, g of x plus x. So that's low times d high, so that's 3f prime of x, minus high, so it's 3f of x. And this is where I'm saying being careful with parentheses is useful. So the derivative of low is going to be g prime of x plus 1. But I need to be careful with parentheses because this plus 1 is also multiplying the 3f of x. Then don't forget the low, of course, so that's going to be g of x plus x squared. Not x squared, x squared, low squared. So low d high minus high d low over low low. So now what we're going to do is we are going to plug in our 1 value. So let's do that. Anytime I see an x, I'm going to plug in 1. So h prime of 1 looks like it's going to be g of 1 plus 1, because we're plugging in 1 for x, times 3. Well, what's f prime of 1? Well, f prime of 1, we will evaluate later on, minus 3f of 1 times g prime of 1 plus 1 at the very end. And then finally, it's going to be g of 1 plus 1 squared. So again, the plugging in 1 isn't very bad because all you do is you replace your x's with 1s. But let's find all of these numbers. And hopefully I can just erase what we need to find because I sort of ran out of space, as you can tell. But let's find g of 1 first. Well, g of 1 is going to be the y value of the g graph at the point 1. So if you take this point 1 and you go up to the function, notice that it's going to be 4. So in this case, what is g of 1? So we can erase this g of 1. That's just going to be 4. What is g of 1? Well, that's just going to be 4. So now let's try to find f of 1. F of 1 is going to be this value right here. So this value is actually a little bit hard to see, but what you can do is you can do two different things. A, you can be good at rising and running using your slopes, so you can sort of just eyeball it. But if you want to be very, very careful with this, what you should do is you should come up with the equation of this line right here, and then just plug in 1. So I'm going to do this in the middle-ish part where we have some space here. So I'm going to find the equation of this line. In order to find the equation of the line, I need slope and point. But the slope is not going to be too bad because I'm going to do the slope between these 2 points, 2, 0, and 0, 1. Keep in mind that when I find the slope at this number right here, I can find the slope of the entire line because the slope is consistent along the line. There's going to be 0 minus 1 over 2 minus 0. So the slope is going to be m is equal to negative 1/2. 0 minus 1 over 2 minus 0. Again, all I'm going to try to do is I'm trying to find this y-coordinate, but I don't trust myself in just eyeballing the graph. The graph is not a very pretty graph, so I want to make sure I get the right number. So I'm trying to find the equation of the line. So keep in mind that the y-intercept is 1, so I already have my equation. It's going to be y is equal to negative 1/2 x plus 1. So now that I have the equation, I can be sure and I can be guaranteed that I will have the correct number. So notice when you plug in 1 here, when you plug in 1, you'll get negative 1/2 plus 1. So it looks like our f of 1 value is going to be 1/2. And it should be fairly obvious that it is 1/2. But again, if you want to be careful, what we did is we found the equation of this line right here and we plugged in 1 just to make sure. So now what we need to do is find some g prime values and f prime values, but again, those are going to be slopes. G prime of 1 is the slope of this entire line, but notice this line is pretty nice because this line is horizontal, so the slope is going to be 0. So g prime of 1, I'm not going to complain, but that's 0. But this plus 1 is still multiplying the 1/2. And then f prime of 1, we actually already found as we did this sort of table here, as we found the slope. I don't know what I'm saying anymore. But notice it was negative 1/2. And what students mess up is that they try to find the slope at this point, but it's really difficult. But again, you can find the slope at any point along the line. So I just do y2 minus y1 over x2 minus x1 between two obvious points. In this case, 0, 1, and 2, comma 0. So this slope was negative 1/2. Negative 1/2. So it looks like we should be able to find the actual answer. So it's going to be 5 times 3, which is 15. So it's negative 15 halves minus 3 halves all over 5 squared. So we can write 5 squared. And then negative 15 minus 3, that's negative 18. Negative 18 divided by 2 is negative 9. So it looks like our final answer is negative 9 over 4. So again, nothing too crazy. All we're doing is we did quotient rule, and then after we did quotient rule, we plugged in the number we wanted, which was 1. But unfortunately, as we plugged in 1, what we needed to do is we needed to find some slopes in order to find those slopes. And why did we need to find slopes? Well, we needed to find these values, and f prime and g prime values are slopes, and f and g values are y values. And again, if you want to find a point that you might not be sure exactly where it is, what you should do is just be safe, write the equation of the line, and then plug in that x value, for example, 1 in this case, into our equation of our line. But once you do that, and you're careful with quotient rule, you're careful with these points and slopes, you should be good to go. So let's do maybe one more question. Maybe a trickier question. So let's erase this. Let's erase. Let's take a little bit of a harder function. Let's just let's do h of x equals 3 times g of x minus, let's take it f of, let's say 2x, I want x minus 4. Do I want x minus 4? Let's do actually x minus 5. What do I actually want? I want x minus 3. So what we're going to do is we're going to take this function and we're going to try to evaluate the derivative, h prime of x. And we're going to try to do it at the number x is equal to 5. So last one, a little bit of a tricky one, but let's try to take this derivative. So as you take this derivative, what will happen is that h prime of x will equal, well, this derivative is pretty easy. It's 3 times g prime of x. Then we're going to take this derivative right here. Technically, this is the chain rule, but the inside function is so easy. But you can certainly employ the chain rule. It's going to be f prime of x minus 3. And then we need to multiply by the derivative of x minus 3, but that's just times 1. We can write times 1 if you want, or you can leave it out. But again, it's still nice to notice that we do have to do chain rule. So now what we're going to do is we're going to plug in 5. Nothing going to be too crazy here. H prime of 5, at least at the beginning. G prime of 5 minus f prime of 2. So finally, what's g prime of 5? Let's practice again. Well, we want to find g prime of 5. G prime is going to be a slope value. It's going to be the slope along this line. So we do need to find the slope of this line. Again, what you can do is you can find the slope along the entire line itself. So let's just do y2 minus y1 over these clear points. It's going to be 3 minus 4 over 5 minus 3. So this slope is also negative 1/2. So this is going to be 3 times negative 1/2 here. Equals, and then we do f prime of 2. So we're not looking at 5 here, we're looking at 2. And 2 is kind of weird because 2 is a sharp point. So this is where the question becomes weird, because what is the slope of 2 of the function f? Here's my function f, here's the point 2, what's the slope? well, I can consider the slope being this, the slope of this little line, or I can consider the slope being of this line. But you can't have two slopes, so this slope actually doesn't exist. The derivative of f at 2, meaning f prime of 2, doesn't exist because we have a sharp point. The sharp point, which is called a corner potentially, is the main example being absolute value. That's one of the main examples of a derivative not existing, because you can't have two slopes, so you have neither slopes. So actually in this case, we're going to get 3 times negative 1/2, but f prime of 2 does not exist. Because again, at 2, there's two functions and meets at these two like a v. So you can't choose this slope or this slope, so you have to choose neither of the slopes, which means that the derivative is going to not exist. So what's this answer? Well, what's negative 3 minus does not exist? That's just going to be does not exist. Anytime you have does not exist up here in the question, the final answer will be does not exist. So hopefully this makes sense. Again, as we were taking the derivatives, we did our normal chain rule, we did our normal product rule, we did our normal quotient rule. And these graph functions are a little bit harder than the table because the table just spits out all the things you want. So for these graph things, first thing that's important is that f and g values are function values, which are y values. So you're just looking at the y values. You might want to find the equation of certain lines and plug in the x values to find exact y values. And finally, f prime and g prime values are slopes, which you can read either from rising and running, or you can do y2 minus y1 over x2 minus x1, and just be careful that the slope of the entire line is consistent over the entire line, which means that you can do y2 minus y1 over x2 minus x1 for the entire endpoints. Keep in mind that when you're doing these questions, you might get strange answers like does not exist if your slope doesn't exist and that occurs at a sharp point, like 2 here or like 3 here if we were involving the function g. But that's how you do graphs. Again, one step harder than those tables, but hopefully you know how to gather information from the graph, y values, slope values, and when the slope doesn't exist, meaning when the derivative doesn't exist. And that's it for this graph question. I'm going to do one last thing, which is talking about the chain rule presented in a different way because it's sort of a miscellaneous question. So you're probably used to the chain rule that we talked about earlier in this form right here. The derivative of this guy is going to be f prime of g of x times g prime of x. That's the chain rule that we're used to, but sometimes we like to write it in terms of Leibniz. So what we're going to do is we're going to have a function y equals, and we're going to have a function u equals. And both of these are going to be in terms of x's, so there's going to be x's in these questions. And what we want to do is we want to find the derivative of dy dx. So to find dy dx, what we want to do is write the chain rule in terms of Leibniz. So what the chain rule is, and written in Leibniz is, and what I tell my students, is that it's dy du times du dx. So sometimes people don't like writing it with primes, but it's the same thing. What you do is you take the derivative of the outside function, keep the inside of this function the same, and then finally you multiply by the derivative of the inside function on the outside. But you can just memorize this formula. You can also think of this as a fraction where the du's cancel, so that's why you're left with dy dx. But what the chain rule allows me to do is it allows me to find the derivative of y with respect to u, even if both functions are given in terms of x. So let's see an example of this, and then we should be good to go. So let's say we have y is equal to x cubed plus 1, and let's say u is equal to sine of x. And notice that both of these functions are in terms of x, but I want to find dy du. I want to see how is y changing when u is changing, and not how is y changing when x is changing. So what we're going to do is we're just going to use this formula right here. What do we need to isolate? Well, we need to isolate dy du. So what should we do? We're going to take this du dx and take it to the other side. So it looks like this derivative is going to be dy over dx divided by du dx. And then we're just going to take this easy derivative. So we're going to, basically it's just the derivative of one divided by the derivative of the other. So what's our final answer? Well, dy dx's derivative is just going to be 3x squared. What's the derivative of sine of x, which is du dx? That's just going to be cosine of x, so this is our answer. So again, one last question, which was about chain rule. Chain rule can be written as this form right here, the derivative of the outside times the inside, so this is Leibniz's notation. Sometimes what you want to do is, if functions are both in terms of x's, what you want to do is you want to try to find dy du, how does one variable affected by another variable, even if they're not defined in terms of each other. But by using the chain rule, we can take this guy, divide it by the other side, so we arrive at this formula. So this derivative ends up being the derivative of the first function divided by the derivative of the second function. And that concludes our example. So we did a lot today. Even if this was a gentle lesson, we talked about derivatives sort of in a general way: product rule, chain rule, quotient rule, and power rule. And we took all those derivatives in terms of functions involving f's and g's. And after we took these derivatives of these functions involving f and g's, what we did is we used a table to potentially find f prime, g, or g prime values, or we used a graph to find f prime, g, and g prime values. And the table is very easy because the table is a table. And in the graph, to find f and g values, those were y values. To find f prime and g prime values, those are derivative values, so those were slopes of those line segments. Finally, we did a quick little Leibniz chain rule lesson where the derivative of dy du is the derivative of y with respect to x divided by u with respect to x. And that's it. But even if I thought this was going to be a gentler lesson than it actually turned out to be, of course, if you want more practice, what I'll do is I'll link the description of our Girls Teach Calculus video and the description of this video, where one of my former students practices several of these examples. She has two big tables where she takes a lot of derivatives. They involve square roots, they involve squares, product rule, and chain rule, and things like that. And she plugs in numbers, and she uses those two tables. So be on the lookout for that. Also, she does a few of these questions, and then finally she concludes with some graph questions, where again, your function values are going to be your y values, and your derivative values are going to be your slopes. So watch that video if you want. This has been another lesson in our derivative topics videos. Keep watching if you want to sort of complete our playlist of derivative topics. But just like normal, we really do appreciate you watching this video. Give us a like and subscribe if this was useful for you at all. And until then, thanks again for watching.